Good evening. Welcome to NPTEL classes. Today I am here to solve chemistry class 12th NCERT problem 2.29 from unit 2nd, that is solutions. Problem in fact has two parts. Let me make you understand part 1. Morphine is a drug of composition C19H21NO3 and is used to treat withdrawal symptoms of morphine in patients, and recommended prescribed dose of morphine is 1.5 mg. 1.5 milligram is the prescribed dose of morphine given to patients in order to treat withdrawal symptoms of morphine in them. Now we need to answer what is the mass of water required in order to prepare 1.5 into 10⁻³ molar aqueous solution of morphine, considering aqueous solution has 1.5 mg of morphine dissolved in it. We have to make 1.5 into 10⁻³ molar aqueous solution of morphine, and for that mass of morphine to be used is 1.5 mg, which is its prescribed dose. Now we need to calculate how much water we have to take in order to make this solution. So after understanding this problem, I got to know that molality of aqueous solution of morphine is given 1.5 into 10⁻³ and unit of molality is mole per kg. Now morphine is solute here, and its prescribed dose contains 1.5 mg, which is, when expressed in grams, it is equal to 1.5 into 10⁻³ grams. Now we have to calculate mass of water that is required in order to form its 1.5 into 10⁻³ molar solution containing this much mass of morphine, which is prescribed dose. Mass of water we need to calculate. How much mass of water we need? So problem is based on concept of molality. Simple. Idea is simple, that we have to use molality equation. Molality is equal to, what is molality? Number of moles of solute present in 1 kg of solvent, and its applied equation is molality is weight of solute, dissolved mass of solute, multiplied by 1000 into molar mass of solute multiplied by weight of solvent, here water, in grams. This we need to calculate. Now molality is given, dissolved mass of morphine is given, molar mass of morphine we need to calculate, and for that purpose only composition is given C19H21NO3. For that purpose, in order to calculate, in order to find mass of water required, we need molar mass or molecular mass of morphine, and for that very purpose formula of norphine is given C19H21NO3, and from formula we can calculate molecular mass by adding atomic masses of all the atoms present in molecular formula, and upon calculation it comes 311. So I can substitute first values. Molality is equal to 1.5 into 10 raised power minus 3 is equal to, dissolved mass is also equal to this 1.5 into 10 raised power minus 3 multiplied by 1000 divided by molar mass is 311. When we add atomic mass of 19 carbon atoms, 21 hydrogen atoms, 1 nitrogen atom, 3 oxygen atom, it comes 311 multiplied by mass of water in grams. So W1 mass of water will be equal to, W1 will be equal to 1.5 into 10 to the power minus 3 multiplied by 10 to the power 3, 1000 means 10 to the power 3 divided by 311 multiplied by 1.5 into 10 to the power minus 3. 1.5 into 10 to the power minus 3 and 1.5 into 10 to the power minus 3 will get cancelled. So W1 will be equal to 1000 divided by 311, and it comes equal to 3.2 grams. 3.2 grams. This is the mass of water. Mass which we needed to calculate. Mass of water required. Mass of water required is 3.2 grams. This is answer, or I may say this is solution of part first, which was based on concept of molality, for which I used molality equation. Now coming to part second, let me make you understand part second. Solubility of hydrogen sulfide gas in water at HTP is given but expressed in terms of molality. This problem is also based on molality, and how much? 0.195 molar. Now we have to calculate Henry constant of hydrogen sulfide gas at HTP at standard temperature. If partial pressure of hydrogen sulfide is 0.982 bar. Hydrogen sulfide, before I proceed to solve this problem, let me give you some information of hydrogen sulfide. Hydrogen sulfide is gas. It is toxic gas. It is toxic in nature, so we need not to inhale it, and it is toxic. It shows its toxic effect upon when its concentration in body reaches up to certain level. Below that level it is not toxic, but above that level it can prove toxic. So first point is hydrogen sulfide is a toxic gas. Second is it has rotten egg like smell. It has characteristic smell, and that smell resembles with rotten egg smell. Next, it is used in laboratory in qualitative analysis so as to detect elements. During detection of metals, it is used. Hydrogen sulfide gas is used in laboratory, and for its use, teacher and student goes have to go outside the lab in order to use hydrogen sulfide gas, where they can breathe in fresh air after use. Now, solubility of coming to problem. Solubility of hydrogen sulfide in water at HTP is given, and how much its solubility is given, but expressed in terms of molality. Coming to part second. Part second. Its molality which represents its solubility. Molality of hydrogen sulfide which represents its solubility at HTP in water is given, and how much? 0.195 molar. Now what we need to calculate? We need to calculate Henry constant. KH we need to calculate. What is given? Partial pressure of hydrogen sulfide. Partial pressure of hydrogen sulfide is given at HTP 0.982 bar. So this problem is based on solubility. What is solute here? What is the nature of solute? Hydrogen sulfide gas. What is solvent? Water. We have to dissolve hydrogen sulfide gas in water, and maximum dissolved molality is maximum dissolved molality of hydrogen sulfide at HTP is 0.195 molar, which becomes its solubility. Now we have to calculate Henry constant of hydrogen sulfide at 0 degrees Celsius standard temperature, given is partial pressure of hydrogen sulfide in atmosphere. So idea is we have to use Henry law equation here. Henry's law equation. We have to use Henry law equation here in order to solve the problem. Henry law equation, and Henry law equation is partial pressure of hydrogen sulfide gas above water will be equal to product of Henry constant at standard temperature and its mole fraction in gas. This is the actual form of Henry law equation that we need to hear in order to calculate value of Henry's constant, and value of Henry's constant will be equal to. Now let us first recognize what are given and known parameters. Partial pressure of hydrogen sulfide is given 0.982. Henry constant we have to determine. This is given. This we have to determine. And for determination of Henry constant, we must know mole fraction of hydrogen sulfide gas present in solution. We must know mole fraction of hydrogen sulfide gas in water in solution. So first we have to do some homework. Homework is that we have to calculate mole fraction of hydrogen sulfide. Now what is mole fraction equal to? Mole fraction, hydrogen sulfide is solute. I will represent it by 2. Mole fraction we have to determine. What is mole fraction? Ratio of moles of solute and moles of solution, N1 plus N2. What is the number of moles of solute? Number of moles, molality. From given value of molality, I can determine number of moles of solute. What is definition of molality? Number of moles of solute present in 1 kg of water. So it is molality is given mole in units of mole per kg. How many moles of hydrogen sulfide are dissolved in 1 kg of water, 0.195. So moles of hydrogen sulfide are equal to 0.195. Now what is the number of moles of water? Number of moles of water I also can determine from given mass of water. That I mean from definition. Here I am just utilizing definition of molality in order to find number of moles of solute and number of moles of solvent. Molality means number of moles of solute in 1 kg of solvent. Since molality is given 0.195 mole per kg, so moles of solute are 0.195. Now I have to calculate moles of solvent. That too I will determine from definition of molality. Definition says me I have 1 kg of water, and 1 kg of water means 1000 gram of water. 1000 gram of water, and I need to calculate moles of water. For that I need to divide mass of water by its molar mass, which is 18 plus 0.195, and it comes equal to 0.195 divided by 55.55. Let me write here. Chi2 is equal to 0.195 divided by 1000 by 18 comes 55.55 plus 0.195. Now mole fraction of hydrogen sulfide in water is equal to, it comes equal to 0.195. This comes equal to 55.695, and it comes equal to 0.003. This is the mole. Here in this equation, I will come back to the main equation, actual Henry law equation. Here in this equation, partial pressure was known parameter, Henry law was the parameter that I need to calculate in this problem, and mole fraction was needed parameter. First I had to determine mole fraction of hydrogen sulfide. For that I used idea of mole fraction. It is the ratio of number of moles of solute and number of moles of solution. Number of moles of solute and number of moles of solvent I got from definition of molality, given molality, and after substituting number of moles of solute and number of moles of solvent, I got that mole fraction of hydrogen sulfide gas in water or in solution is 0.003. Now I can easily do substitution in this equation. I need to calculate Henry constant. Henry constant Kh will be equal to ratio of partial pressure of hydrogen gas and mole fraction of hydrogen gas. Partial pressure of hydrogen gas is given. Partial pressure of hydrogen sulfide gas is 0.982 bar. Mole fraction is 0.003, and answer Henry law constant Kh will come equal to, Henry law constant comes equal to 2.8 into 10 to the power 2, and unit of Henry constant is same as unit of pressure, because pressure was in bar, so unit will be bar. This is the solution or answer of part second, where we had to determine value of Henry constant. From given value of molality, we had to determine Henry constant. What I needed to do from given value of molality, first I needed to calculate mole fraction. Actually, solubility in terms of molality was given, but I had to express this solubility in terms of mole fraction in order to bring it in the form where I can use Henry law equation, which is partial pressure of gas above solution is equal product of Henry's constant and mole fraction of gas in solution. I needed mole fraction, not molality. And in order to determine mole fraction, I used the idea of concept of definition of molality, where from I first got number of moles of solute and number of moles of solvent. Then I determined mole fraction of hydrogen sulfide gas solute. Then I substituted mole fraction in this equation in basic Henry law equation, wherein partial pressure was given parameter, mole fraction was calculated parameter, and Henry law constant I determined equal to 2.8 into 10 raised power 2 bar. Class 12th students, this is what I had for you today. See you on Tuesday, as Monday is reserved for class 11th students. Take good care of yourself and enjoy your Sunday. Allah Hafiz.